Hi guys, it's Miss Wright again. So if you weren't in class today, or if you were and you want a refresher, I'm going to go over a few problems for your notes. Here we go. So let's start off with formulas, two names. Let's start off nice and easy. This is one of the problems you saw last week at Jupiter Ed. First step, this is a metal, this is a non-metal. I use my periodic table to do that. Right. Now I know that it's ionic. Opposites attracting, ionic. So I have to use that naming system. Ca is calcium. Calcium only has one possible charge, so I don't need any Roman numerals. Fluorine becomes fluor. Keep the first syllable and then change the ending to "ide." That's it, nice and easy. Let's keep going. And the next one we're going to look at is a little tougher. Again, this is from your work from Friday. Chromium is a metal. Sulfur is a non-metal, so this is ionic. Okay, next, chromium has possible choices. So chromium, this is the name. But I have to have a Roman numeral. I have to have a space here because there's different kinds of chromium. +2, +3, +6. We don't know which kind yet. Sulfur becomes sulf, ide. Now, to figure this out, we have to do simple math. There are two chromiums, so two of something. Again, we don't know what it is yet. And 3 sulfurs. Sulfur's negative charge, sulfur only has one possible negative charge, -2. And that's from the periodic table. You just go look it up. We know it has to add up to 0. This whole compound is neutral. It has to balance the charge. So 2 times what will make this true? Well, we have choices. Chromium can be +2, +3, or +6. This is from the periodic table. Which one of these will make this statement true? Take a second. Hopefully you said +3. 2 + 3s is +6. 3 -2s is -6. And that will add up to 0. So my final answer, right, since it's +3, Roman numeral 3. Okay. Now we're going to go in the opposite direction. This is when you have a formula and you have to write the name. What if they give you the name and you have to write the formula? Okay, we've just got 2 more problems to do. Again, first step is always, this is a metal, this is a non-metal, I have to use the ionic system. Remember, covalents have a different system. Polyatomics have their own naming. So you have to know this first. Iron is Fe, and they're telling us it's iron 3. Iron, if you look on the periodic table, could be +2 or +3. They're telling us in this problem by putting the Roman numeral 3 that we have to use the +3. Sulfur, S, and if I look it up, its only negative charge is -2. When sulfur comes at the end like this, it has to have that negative charge. Cation, anion. Not done yet. This is not the formula. This is the work to help us to get the formula. We can use something called the crisscross method because these charges don't add up to 0, do they? +2 and -2, that adds up to +1. That's not possible. It has to add up to 0. So here's a trick. Put the 2 here and the 3 there. Notice there's no charges. This is a trick Notice how it balances the charges for you. 2 positive 3's plus 6. 3 negative 2's minus 6. Using this trick, you can get the charges to balance. It'll add up to 0. Plus 6 minus 6 adds up to 0. Notice it's right, 2 sets multiplying. It's not 5, right? 2 sets of 3. Okay, so my final answer, I can't reduce 2 to 3 anymore. Ionics do need to be reduced if possible, but this is already reduced, and I'm done. Notice my final answer does not have the charges in it. That's important. Okay. One last one. Okay. Okay. First step, aluminum is a metal. Phosphate. This is different. This is not phosphorus, it's phosphate. This is a polyatomic. Okay, you can find them on table E. Okay, so you always have to look there. So that's going to be a slightly different naming system. So let's get going. Aluminum is just Al, and if I look it up, it has a +3 charge. You do have to look up the charge. You can't write a formula correctly without it. Phosphate, I don't look on the periodic table. I have to go to table E. It's a group. Okay, so it's PO, notice it's capital 4, and notice that's all inside. That's the group, and it has a 3 minus charge. Again, I get this from table E. I'm not making it up. I'm not guessing. Okay. Now, there's 2 ways to do this. +3 minus 3. You can notice it's already balanced. And then I can just write Al PO4. Done. It's already balanced. Or if you want to, you keep using the crisscross method. I use the crisscross method, 3. Notice the 3 goes on the outside of the parentheses, but 3 to 3 can be reduced. So I can reduce it to 1 to 1. So I still end up with Al1, PO4, 1. Okay. So notice the 4 doesn't go away, right? That's part of its own little group. You can't undo or change that in any way. Okay, we're going to do a project on this, so make sure you're ready, and hope you have all the notes. Thanks.